This is a RLC math tricks problem. It's an overdamped circuit, but they've kind of mixed up the knowns and unknowns to make you play around with the math in a little bit more challenging way. So we've got a resistor, 250 ohm. We've got an inductor that's unknown quantity and a capacitor of unknown quantity. We've got V0 is equal to 0, so this capacitor is uncharged. And we've got I sub 0 is equal to 45 milliamps. There's I sub C, there's, I sub L, there's I sub C, there's I sub R, all leaving node A. It's also given that they've given you the time response of the current through the capacitor. So I sub C as a function of time is A1 e to the minus 200t plus A2 e to the minus 800t. So this is a current response. Now our general response for these circuits so far we've been mostly concerned with the voltage response here. And the voltage response has this characteristic form. Well, all of the new part here is that all of these signals, I sub C, I sub L, I sub R, they will all have this same characteristic form. They will only differ in these coefficients here, these A1 and A2 coefficients. So there's going to be different A1 and A2 coefficients, all right, for each signal, for each, the voltage signal and the three current signals will all have the same format, but they'll have different constants in front. So that's kind of the new thing they're making us work with here. But we've seen that before, but here it's a key part of the problem. So useful stuff here. V equals IR, Ohm's law, right? And V equals Li prime. This, by the way, this V equals Li prime applies to inductors, right? So, I mean, you could put the sub L and the sub L here. It's kind of messy, but it is understood, right, that when you say V equals Li prime, you're talking about an inductor. And I equals CV prime. Of course, we're talking about capacitors when we say that. We have KCL. You know, KCL is just a sum of currents. You can take the derivative through an equation like that. I mean, you can take the derivative across any equation, right, through all the terms in that equation. So that's another thing we're going to do. And while we're talking about these funny this math, I'm pointing out this math here thing. This problem, they give you this hint. And the hint is that I sub C, well, here I'll sort of derive it a little bit, but you know, I sub C is minus I sub L minus I sub R at 0. It's just KCL, right? All three of these guys leaving would sum to 0, and then solving for I sub C, you end up with this expression. These two terms would be negative. Okay, you can take the derivative through this expression, right? So let's do that. So IC prime, IL prime, IR prime, right? Just take the derivative through this thing. And then we can apply this guy here, right? I sub L is going to be V sub L over L, right? So this term here is going to be V sub 0 over L. And then this term here we can apply we can apply this one. So for v, just the v prime, what they've done what they've done here is they've taken the derivative through this thing. So v prime, since r is a constant, it's going to be ri prime. So this is I sub r. So I sub r is going to be v prime over r. So I sub r prime is going to be v prime at 0 over r. And then carrying this same term down here, this term down, just carry it straight down. And now this guy here, we have v prime at 0, they're applying this thing. So v sub c prime is going to be I sub c over c. So taking out factoring out the r, and then just replacing this v prime at 0 with I sub c over c, it's going to be I sub c at 0 over c. So I c prime at 0 is going to be this thing. This is a hint. You know, save this guy for later. So this is a hint that you would never probably ever derive this on your own, but you know, there it is. And it works with the knowns unknowns kind of problems that we're doing. They're giving you certain things and they're asking you to find others, just to make you work with the math, to make you run the math through your head so that you can remember it better and feel more comfortable with it. So anyway, they give you this really roundabout sort of hint, and they're asking you to find part A, alpha, omega 0, the inductance, the capacitance, these A1 constants, A1 and A2. And then they're asking you to find V as a function of time, I sub R as a function of time, and I sub L as a function of time. So jump right into this thing. So part A, the solution for alpha. Once again, just like this, how you would probably never come up with this crazy expression on your own here. It's just unlikely that you would think to go through these series of operations to get this guy, but there it is. Likewise, you would probably it would be unlikely that you would consider doing this. But if you did do this, we have a formula for S1 and S2. And if you added them together, you would get S1 is minus alpha plus root alpha squared minus omega 0 squared. And S2 is minus alpha root alpha squared minus omega 0 squared. And we're adding these two, but the definitions of these have the negative sign. So this is correct. It looks like it might be wrong, but it's fine. Okay, this thing here, this is by the characteristic equation, this 200 is S1. And so S1 is 200 and S2 is 800. So they're giving you they're giving you S1 and S2 by giving you this I sub C expression. They're giving you S1 and S2. So minus. So S1 is minus 200 and S2 is minus 800. And because you have a plus here and a minus here, these two terms cancel. There's a negative in here. And you're left with minus 2 alpha. So alpha works out to be 500 radians per second. So that's our first answer. So it's a trick that is improbable, but there it is. Okay, that was the solution for alpha. So the solution for omega 0, we can go back to our formulas for S1 and S2. S1 is minus alpha plus root alpha squared minus omega 0 squared. We just solved for alpha, and we're given S1 is minus 200. So minus 200 equals minus 500 plus root 500 squared minus alpha 0 squared. The only unknown here is omega 0 squared, and skipping the algebra, you would get omega 0 as 400 radians per second. So that's the solution for omega 0. The solution for C, the capacitance, and we're not given the capacitance, we're asked to solve for it. We have this formula, alpha equals 1 over 2 RC. Okay, so, C, solving for C is going to be 1 over 2 R, and moving the alpha down, switching alpha in C's place, so alpha would go here, 500. It's going to be 4 microfarad. The solution for L, we have this formula, omega 0 equals 1 over root LC. So L is going to be, you square both sides and then swap the L and the omega. You're going to get 1 over omega 0 squared C, which is 1 over 400 squared. Omega is 400, omega 0 is 400. And C is 4 times 10 to the minus 6. So you're going to end up with 1.5625. Lots, way more decimals than I need. Henry's. That's solution for L. The solution for the A1 and A2 coefficients in this expression here. They're asking for those explicitly, and we're going to need those. We're going to need an expression for I of C so that we can do our various tricks over here to get these other guys. But anyway, A1 and A2. A1 and A2, we have our toolkit EQs. We have I sub C at 0 is A1 plus A2, and I sub C prime at 0 is A1 S1 plus A2 S2. Okay, I sub C at 0 we were given. That's the same as big capital I sub 0 is 45 milliamps. So we have these S's, S1 and S2. That's here, minus 200 and minus 800. If we had I sub C prime at 0, then we would have a system of equations with 2 unknowns and 2 equations, and there would be a solution. So basically, we need I sub C prime at 0, and then we'll come back to this thing. So start a new page here because a lot to do. So at this point we can apply our hint. we're trying to get I sub c prime, and we have this hint formula where I sub c prime is all of these other dudes that I think we have all of these things. Yeah, we have L, R, I sub c at 0, c. Yeah, got all this stuff. So I sub c prime at 0 is, I'm just rewriting this thing, it's minus v at 0 over L minus 1 over R, I sub c at 0 over c. And that is 0 over L, which is going to be 0, and 1 over 250. And then I sub c at 0 is 45 milliamps. And the capacitance is 4 microfarad. So this ends up being minus 45, and it has units of amps per second. Okay, that's I sub c prime at 0. So we can go back and plug into our coefficients back here. And so plugging this stuff back in here. So basically, just rewrite this stuff. So I sub c at 0 is A1 plus A2, and it's 45 milliamps. And I sub c prime at 0 is A1 minus 200 is S1 plus A2 minus 800 is S2. And that is minus 45 amp seconds we just solved for. So there's two equations, two unknowns. The solution is going to be minus 15 milliamps and 60 milliamps. Answer. So what's next? So now we got to do part B, VT. Okay, so here's the insight. All of these equations for a overdamped system are going to have this format. All of these signals are going to have the same format. So you're given one signal, I sub c of t, but v of t and I sub r of t and I sub l of t will all have the same format. They will only differ in their coefficients. So that's the insight, is all signals are similar format. You know, differ only in coefficients. So basically, v of t is going to have the format, and we'll use A's because that's what we use for an overdamped system, is A's. It's going to have the format A e to the S1, which is minus 200t, plus A 4 e to the minus S2t. Okay, so this same general format, but with different values for the coefficients, same S1, same S2, all right? And then we have our toolkit. This is our toolkit equations. A3 plus A4 is 0, and V prime at 0 is A3 S1 plus A4 S1 S2. Okay, these are our, well, equals 0 is, well, our toolkit equation is just, you know, up to here, right? But we know that V at 0 is 0. That's given. So that's where this 0 comes from. And then this V prime at 0, that, we have that. Seems like we did that. No, we haven't done that yet. So we need that. So we need V prime of 0. And we'll use this guy. We'll use I equals CV prime. So V prime at 0, so we'll use I equals CV prime. So V prime at 0 is I through sub C at 0 over C. it's going to, this is going to be, I sub C was given as 45 milliamps. So 45 times 10 to the minus 3 over the capacitance we've solved for, 4 microfarads, 4 times 10 to the minus 6. This is going to be 11,250, and the units, since it's rate of change of voltage, is going to be that voltage seconds. So plug this over here, 11,250, and we have two EQs, two unknowns, right? And then the solution for that is going to be, well, plugging in the S's, right? We know S1 and we know S2. You plug those in, so, just to make a note, after plug in S1, S's, plug in the S's, you're going to get A3 is 18.75 volts and A4 is minus 18.75 volts. So back to our V of t general form thing. V of t is going to be 18.75 e to the minus 200t minus 18.75 e to the minus 800t volts. That's an answer. Put a box around it. Then part, we need this I sub r thing. So the solution for I sub r, this was solution for V sub t. Solution for I sub r, we're just going to use I equals VR. I equals V over R, V equals IR, right? Then, so I sub r of t is just going to be V of t over R. So divide through this thing here by 250, the value of R, which is given. So just dividing this guy through by 250, you're going to get 75 e to the minus 200t minus 75 e to the minus 800t. That's I sub r of t amps. And this was volts, and we're dividing by ohms, amps. And then the solution for I sub L of t is going to be, we're just going to use KCL. So I sub L of t is minus I sub r of t minus I sub c of t. It's going to be, we're subtracting this guy, right, minus what? I sub r of t minus I sub c of t. Where is I sub c of t? Where is that? I didn't do it. It's so, here, I sub c of t, just, it's going to be our general solution now that we know that now we know our a's, right? It's going to be minus 15 e to the minus 200t plus 60 e to the minus 800t. Going to be there. Yeah, so subtract this from that, right? So 15 or 75 minus the negative 60s is 60 e to the minus 200t minus 75 and 60 is going to be 15 e to the minus 800t. And this is amps. This is, I got a milliamps in here floating around somewhere. These are milliamps, so this is milliamps. This milliamps. I think this is milliamps, because 250 is kind of big. Yeah, I leave out a lot of the 10 to the powers of, right? When you guys are doing these on your calculator, what I do is I key in all the full number with the 10 to the, the 10 exponent here. And the other thing I wanted to point out is, as I do in the actual lecture, is try and be neater than this. And you guys are neater than this on your homework, but please, I wish I could be that neat, but it's really difficult to talk about this stuff and think through it and be neat. But if I was going to turn this in to my teacher, now that I have the solution here, which is pretty neat considering I know the solution, but if I was doing it from scratch, like you guys are doing it, I can imagine your first draft would be a mess. But once you have the solution, rewrite it neat, and then expand on this narrative, what I'm doing here. You write at least this, maybe even a whole sentence on what you're doing, and then describe here what's happening. Start with KCL, take the derivative, apply this, and write all that stuff down. Okay, that's what I'm looking for, because as I've said in class, a lot of what engineers do is longer term projects that you have to break up into pieces and describe what you're doing and make schedules and plans, and otherwise you can't get anything done. So that kind of organizing your work skill is really important. Anyway, that's the answer. That's the last answer. It's all our i's, I sub c, I sub l, c in there, l, and b of t. All right, great, nice problem. Just some fun math. Okay.